Welcome to GES Digital Intervention Program for Senior High Schools. This is Mathematics Lesson 1 on Algebra. And today, we shall be looking at how to write and simplify algebraic expressions. I am your facilitator, Nala Dabu. Now, to kick us started in our lesson and to keep the brains warm, let's do this simple exercise. I'm going to give you 4 numbers. You're going to combine these numbers to get a value of 24 using the 4 basic mathematics operations. That's addition, multiplication, subtraction, and division. No digit should be repeated, but you can repeat the operations as many times as you want. Now, let's look at the first set. 18, 12, 2, and 4. I'll give you 5 seconds. Good. I know that you have different ways of combining them. I'm only going to show you how I did mine. First, I divided 18 by 2. I multiplied the results by 4. Then I subtracted 12. How did you do yours? Now let's look at another set. 5, 7, 4, and 21. Remember, every number is used only once. Okay, now let's combine your solution with mine. This is how I did mine. First, I added 7 to 5. I divided the result by 4. Then I added 21, and that gave me 24. How did it go? Now that we've started, let's look at what we shall learn today. Today, we shall be learning how to express statements into algebraic expressions. And we shall also learn how to write algebraic expressions into word statements. But first, let's look at some keywords that we will meet throughout the lesson. Place value, unknowns, variables, symbols, algebra, simplify, expressions, and of course equations. I know these keywords are familiar to you all. In our lesson outcome, the first session will deal with writing word statements into algebraic form. And the second session will be the opposite, expressing algebraic expressions into word statement form. But first, what is an algebraic expression? In fact, algebraic expressions has actually come to take care of all the loopholes that numbers have not been able to do in life. So, algebraic expressions is the use of variables or symbols to represent quantities in mathematical expressions and equations. When you want to express statements into algebraic form, there are some steps you have to follow. Let's look at them. The first step is that you have to learn to read and reread your statements very, very well. Then secondly, you have to identify all the various groups of items in the statements that you have read. And of course, the third one, you use variables or symbols to represent each unique item you have identified in your statements. Then if the items are related, you represent the smallest with the variable and express the others in terms of it. Then you think of all the possible mathematical relations or expressions between these various items. You write down the relations or expressions connecting the items. But remember, in mathematics, when we say is, we actually mean equal to. I hope you got that. Now, we have to take note of some points when we are expressing word statements into algebraic expressions. The first one is that, remember, lowercase letters are not the same as uppercase letters. So, for example, small a is not the same as capital A. Some letters also look like numbers, and we have to be very careful about them. I and J, for example, look like 1. So if you want to use I and J as your variables, then you must ensure you put the dot very well. Equally, Z looks like a 2. So if you want to use Z as your variable, it's advisable to cross it, or you write it very well. Use curly X to represent X, not the cross X. The cross X looks like what? A multiplication sign, and you can easily confuse yourself or even confuse your students and the examiners. Remember, S also looks like a 5. Write your 5 very clearly. When it comes to powers, remember the exponent is always raised and it is small. It is always like half the size of the variable or number. And when it comes to subscripts, they are equally small, about half the size of the number or even smaller, and they are lowered. Remember to always write fractions with a horizontal line. For example, 2/3 are written as shown on your screen. X plus 2 divided by 3x must be written with a horizontal line. So the division must be a horizontal line. Do not write 2/3 as 2/3. It looks like 213. And that is very confusing. Be careful when you are dealing with chains of equal signs, because if one chain is wrong, the whole expression is wrong. Let's look at what is on your screen. You see we have 25 minus 17 equals to 25 minus 10 equals to 15 minus 7 equals 8. What can you see wrong here? You realize that the 25 minus 10 is not equals to 8. Therefore, the whole expression you have written there is wrong. Now, let's start with some examples. Expressing word statements into algebraic form. First example. Dakura gave the same number of mangoes to 4 of his friends. How many mangoes did he give out? So you see where algebraic expressions come in to take care of the shortfall of numbers. If we knew how many mangoes there were, we could just go ahead and find it. But now we don't know. So in working a statement like this, you have to read it again and be sure you understand the statement very well. Then you look at for the variable that you have to express. And you can use any variable. You can decide to use A, you can decide to use X, you can decide to use Y. People have been complaining that mathematicians use X and Y. Well, it's very, very easy. So let's look at this question. We can say, let X represent the equal number of mangoes that the crow gave to each of his friends. So you now see that the crow will give 4x mangoes to the 4 friends. How did we arrive at 4x? There are 4 friends, and each friend receives x. So we have x plus x plus x plus x. That's 4x. 4 of them. That will give us 4x. Now let's look at yet another example. Mr. Chandy shared an amount of money in cedis equally among 7 of his children. How much did each child receive? So you see here again, we don't know how much Mr. Dakra shared. So what we can say is, let X represent the total amount Mr. Chandy shared. Now, we'll say Mr. Chandy gave each of his children X divided by 7 cedis, where X represents the total amount of money he shared. And once each child receives equal amount of money, then X divided by 7. Let's look at this question. And I'm going to give you 15 seconds to come out with the answer. The ages of 3 girls, Bola, Stella, and Grace, are such that Bola is 3 times as old as Stella, and Grace is 9 years older than Bola. The question is, write an expression connecting the sum of the ages of these girls and simplify your results. Now, compare your solution to mine and let's see how it went. Looking at the 3 girls, their ages are related. So, I'll represent the youngest age with a variable, and that is Stella's age. So, let X represent Stella's age. Bola's age will now be 3x. That's 3 times Stella's age. Grace's age will be 3x plus 9. Now, summing these ages, I have x plus 3x plus 3x plus 9. And when I'm simplifying, I have x plus 3x plus 3x plus 9. That gives me 7x plus 9. And that is the sum of their ages, expressed algebraically. Again, let's take another task. Express this statement in algebraic form. Half of the sum of twice a number and 7 is 24. 15 seconds. Good. Now let's compare your solution to mine. So I say let the number be b because I don't know that number. But twice the number is 2b. The sum of twice the number and 7 will be written as 2b plus 7. And now half of simply means half times or half into brackets. So finally I have half times 2b plus 7 is equal to 24. Isn't that what you got? You've done very well. Now let's look at another one. The sum of the digits in a 2-digit number is 10. If the digits of the number are reversed, the new number is 6 more than the original. Write down 2 equations to illustrate the information. So this task, I'll give you 30 seconds. I know you can do it. Now let's look at my solution. I'll say let the 2-digit number be xy, where x is the tens and y is the ones. The reverse form of this number is yx. So when you reverse the digits, y become the tens and x the ones. The first statement says the sum of the digits is 10. So if the number is xy, means x plus y equals to 10. That's my first equation. Now when the number is reversed, yx can now be written as 10y plus x. That is the value. Here we are looking at the value of the number, not the digits. And xy will be written as 10x plus y. That is its value. So if the value of the reverse digits is 6 more than the value of the original digits, then what does that mean? It means that when I subtract the original value from the value of the reverse digit, it should give me 6. And so I have 10y plus x minus 10x plus y equals to 6. So here again, I simplify. I'll have 10y plus x minus 10x minus y equals to 6. And this gives me 9y minus 9x equals to 6. And when you divide through by 3, you have 3y minus 3x equals to 2. Now we have our second equation. And that is it. The two equations are x plus y equals to 10 and 3y minus 3x equals to 2. I know you got the same answers. Now we are going to write algebraic expressions into word statements. I know with the examples we have, you can do that. I have 2 examples on the screen. I want to give you 30 seconds to do both examples for us to compare answers. The first one, 2/3 times 3x minus 10. And the second one, x squared times b squared equals to 144. Now, let's compare solutions. For the first one, there are several ways you can read it. This is just one of the ways. So you can add it to the several ways that you were able to read it. I said 10 is subtracted from 3 times a number, and the result is multiplied by 2/3. Now for the second question, I have the product of the squares of 2 numbers is 144. I hope we are following the lesson. Now, to help us understand and grab this concept, we are going to do a little exercise. On your screen, I have 2 sets, set A and set B. One set is algebraic expressions, another set is word statements. You are going to match the boxes, and this will help you consolidate the learning that we have just done. So, dear learners, to help us consolidate our learning and to do the matching very well, we are going to cut out the items in each set. Remember, I told you one is a set of mathematical expressions and the other is a set of word statements that are related. So you cut them out and do the matching. This is what I'll do. First, take one. And then I cut it, then I put them down, then I cut all, so pause. Now I have all the statements cut out, as you can see. I also take the mathematical expressions and I cut them. This is the first cut. Finally, I have all the expressions also cut out. I'm now going to match them. So I spread the expressions, then I spread out the word statement. If you feel that there is an expression or a word statement that does not have an equal match, you will have to do it all by yourself. So I can take any of them now. Take this, says multiply n by 2, then add 6. So I come to my expressions, then I look for it. So here I have 2n plus 6, then I match. Then I take the next one. The next one says square n, then multiply by 9. I come and I look for it. So this is matching 3n all squared, so I match. It's possible that you can have 2 more or more than 2 matching a particular set. It doesn't matter. And if there is no match for any particular set, you have to use the empty spaces to write your own. This brings us